Hi everyone. The second topic of this May 2023, so we'll discuss about dynamic logic. So first of all, we will give the brief introduction about the dynamic. So there is two types logic we are having. One is static logic, another one is dynamic logic. Static means that is fixed one. We cannot change the output based on the inputs. So that is fixed one. Dynamic means we can change during the runtime, that is output getting time. So that is dynamic. So first here we are using the static, pseudo NMOS and dynamic. Three combinations. So first of all we can change. First look at the first circuit. So A is the input, Y is the output. 2, 1, that is the P by N ratio, that is for static gates. And pseudo NMOS, pseudo means already last series we discuss about the pseudo NMOS. So here the pseudo NMOS 2 by 3 and 4 by 3 for pull up network and pull down network ratio, and A is the input that is given only for pull down network, that is lower NMOS device. So the output which is given, that is Y. And next for dynamic logic, we just given the dynamic means you just remind the pi. So pi is nothing but the clock. So here we are given the clock to triggering the external input. So 1 1, it is a P by N ratio, and we can get the output Y. So the dynamic gates which is used the clocked PMOS pull up. So there is two modes here we are using. One is pre-charging, another one is evaluate. So look at the timing diagram. So the timing diagram which is used for clock, pi and Y is the output. So first pre-charge and evaluate. During the evaluation phase only the output will come. So evaluate phase, high output that is given to the low input, that is low output. So low means high, high means low, because we are connecting the inverter. And next we will discuss about the foot, that is one important concept in the foot network. What if the pull down network is on during the pre-charge? So that is the $1,000,000 question. So we can use the series evaluation transistor to prevent this fight. So we can use the pi transistor, that is a pre-charge transistor, and A is the common input, and the foot transistor which is connected, that is downside of the NMOS, that is foot transistor. So if it is needed you can connect the foot network. If it is not needed you can disconnect the footed, that is unfooted. So look at the two diagrams, that is circuit diagram on the right hand side. That is first one, pi is the clock signal, inputs is the input which is given to the pull down network, and again same thing for the another pull down network, that is called foot. Next we will discuss about the logical effort. So the unfoot network logical effort, that is GD, gain of the transistor of the DD, 1 by 3, and again the PD, power, that is 2 by 3, and same thing for another 2 by 3 and 3 by 3 for NAND gate. For NOR gate 1 by 3 and 3 by 3, that is for unfooted network. And for footed network 2 by 3, 3 by 3 for inverter. For NAND gate it is 3 by 3, that is 1, and 4 by 3 for power. And for NOR gate GD is 2 by 3 and PD is 5 by 3. That is the logical effort. So logical effort means it is the effort to bring down the output from the input. So what are the logics you spend to bring out the output? That is called logical effort. So here the main problems occurred, that is monotonicity problem. So what is monotonicity? So first the evaluation phase, if 0 means the output is 0, if 0 means 1, 1 means 1, but if 1 comes means it not comes 0. So you need to bring down the value. So first look at the phase diagram, timing diagram. A is the input and again it is violates. So look at this diagram. Pi is the clock signal, pre-charging evaluation and pre-charging. Y is the output. So normally the Y, the evaluation phase, that is high signal. But during the another output side it must increase, but it is not increased, it is also decreased. So the problems occurred called monotonicity. So we are using this monotonicity problem while we are using the dynamic logic. So this is the monotonicity problem. So here it produces the monotonicity problem, falling outputs during the evaluation. So it is illegal for one dynamic gate to drive another gate. So that is a monotonicity waves. So here the was the A is equal to 1, that is the input, pi is the clock signal, pre-charge, evaluate, pre-charge, again it goes, but x is the input, that is only input. Again we are using the y is the output of the another inverter. So here we are using the another inverter to bring down, that is, if we are using the inverter, the lower signal again it goes to the higher signal. So using this monotonicity voice, we can avoid the dynamic logic gates principle. So next we will discuss about the domino gates in our next series.